Okay, so I suppose on the first question here we've got to find a and b. Now this is a simultaneous equation, so I'm going to solve it using the elimination method. So let me set up the equations one underneath each other, and then let's look at what we can eliminate. So I'm going to eliminate the b's, so I'm going to multiply the top equation by 3 and the bottom equation by 2. So remember, each of those terms have got to be multiplied by 3 and 2. Okay, let's rewrite those equations. It's a really good way just to make sure that we're getting everything correct. So we've got 12a plus 6b is equal to 6, and then we're going to have 12a minus 6b is equal to 12. Alright, so to eliminate the b's there, I would add the two equations together. So I'm going to add each component together, so 12a plus 12a will give me 24a, 6b plus negative 6b is 0, and 6 plus 12 is 18. Now that's pretty easy because all we've got to do now is just solve, guys. So we divide by 24 and we simplify that to 9 over 12, and then we go how many 3's go into 9, how many 3's go into 12, and we're left with a is equal to 3/4. Alright, so now that we know a, all you've got to do is substitute it into one of the equations above and we find b. So I like this equation because to find b we're only dealing with 2b, whereas this one here is negative 3b. Right, so let's substitute a into our equation 4a plus 2b equals 2. So replace the a with the 3/4. We're going to have 4 times 3/4 plus 2b is equal to 2, and 4 times 3/4 will give me 4 3s are 12. 12 divided by 4 gives me 3. 3 plus 2b is equal to 2. Therefore 2b is equal to negative 1. Remember, we bring that 3 across, becomes take 3. And then divide both sides by 2, and we get b is equal to negative 1/2. And there's our solutions for a and b. Okay, this question here is about evaluating an expression, and we have been given a equals 5 times 10 squared, and b is equal to 8 times 10 to the power of 6. Alright, so let's substitute in there our a value and substitute our b value in. What we're going to write is 5 times 10 to the power of 2, so that's a substituted in, and that's going to be divided by our b value, which is 8 times 10 to the power of 6, and that's all to the power of a third. Alright, so let's simplify this. So 5 is 5 to the 1, 1 times 2 is 2, that gives us 5 squared using our index laws, and 10 to the power of 4 when we expand out that bracket. Alright, 8. Sometimes it's easier to change the 8 into a base value of 2 to the power of 3 to then use fractional indices. Otherwise, some of you might know that the cube root of 8 is 2 anyway. So we're left with 2 times 10 to the power of 2, because 6 times a third is 2. Now we simplify, so let's simplify our base value of 10s. We can simplify the 2 on the bottom with 2 on top, leaving with 10 squared. We're going to be left with 25 times 100 divided by 2, which will equal 1,250. Alright, we're going to solve for x for these bottom two questions here. So I can see that we've got a base value of 5, but we've got 25 and 125, which means if we changed each of those to a base value of 5, so 5 squared, and then to the power of x is 5 to the power of 2x, 125 is 5 cubed, and square root 5 is 5 to the power of a half. They all have the same base value of 5 now, so therefore we can say that 2x is equal to 3.5 because we got 3 plus a half. Therefore x is equal to 3.5 over 2. And we now have 3.5 over 2, 7 over 4, because we can double both of those to remove the decimal. Alright, the bottom equation. Well, let's just remove that divide by 4 by timesing by 4. So we times the other side by 4. That leaves us with 2x take 3 to the power of 3 is equal to 64. Now 64, if you're good enough, you can recognise is going to be 2 to the power of 6 or 4 to the power of 3. Now out of those two, which one's going to help us? Well, 4 to the power of 3 will help us because we've got to the power of 3 on the other side. So let's rewrite that out. 2x take 3 to the power of 3 is equal to 4 to the power of 3. Now because we've got the same indices, we can therefore state that the base values must equal. So 2x take 3 must equal 4. So let's just solve this simple linear equation. 2x is equal to 7, and therefore x is equal to 7 over 2. And there we go. Alright, nice little Venn diagram here. They haven't given us a diagram, but probably the easiest way to solve this is by drawing a diagram. So we've got two sets, A and B. And let's fill in those sets using the information we've been given. So the easiest part is the intersection between A and B, which is 5. Let's fill in the rest. 1, 3 and 7 will go in A, and 4 and 6. And let's check our universal set so we've got everything we need. No, we're missing the 2, so it goes on the outside. Okay, so we want to find the number of A intersect B, everything outside of. So A intersect B is 5. There are 6 elements outside of that. Now we want to list the elements of A joined with everything outside of B. So we want to have the whole of A, and then everything outside of B, which is that 2. So 1, 2, 3, 4, 5. There's 5 elements, and let's write them down because we want to list them. 1, 2, 3, 5, and 7. And there's our list. Alright, so a little bit of counting techniques here. A 4-digit PIN number is made by randomly choosing the first 2 digits from subset A and the last 2 digits from subset B. Because we've got 3, 3, we can actually repeat the numbers. So in how many ways can the first 2 digits be chosen? Well, there are 4 times 4 because we can repeat. So there are 16 possible ways. There are 4 numbers in subset A. What is the probability that last 2 digits chosen are both 6s? Well, I suppose an easy way here is we've got 1/3 of a chance of choosing a 6 times 1/3 of a chance, which gives us 1/9 of a chance. Our last question here, what is the probability that the PIN number starts with a 5 but does not end with a 5? So starts with a 5 gives you 1. We've got 2 choices at the end if we can't end with a 5, and therefore the second choice can have 4 choices and the third one will have 3. Now that's going to be all divided by 4 times 4 times 3 times 3. All our possible choices. We can start to cancel out a few things here. We're left with 2 over 12, which is equal to 1 over 6. And there we go. Okay, so we've got some statistics here. So we want to find the mode, which is the most common. Now remember, we can have more than one mode, but here our only mode is 10. It occurs twice. They're asking us also in the second question here to find and determine what scores would be needed to make up a box of whisker plots. So we need our upper quartile and our lower quartile and our median. We already have our highest and lowest. So an easy way is to put the numbers in order, make sure we've got all our numbers, and then start to look at finding our median, so which is halfway between 10 and 11, which would be 10.5. Now we look at our bottom 5 numbers for quartile 1 and our top 5 numbers for quartile 3. So 9 sits nicely in the middle, 13 sits nicely in the middle for our quartile 3, and there are our three other values needed to make our box and whisker plot. Alright, so we want to determine what is an outlier. So we've just done a box and whisker plot, so an outlier would be 1.5 times into quartile range plus quartile 3, or quartile 1 subtract away 1.5 times the interquartile range. So the interquartile range would simply be 13 subtract away 9. Right, so that's going to give us 4. So 1.5 times 4 gives us 6. So let's check. So we go 13 plus 6 equals 19. Anything above 19 will give us an outlier, or we'll go 9 subtract away 6. Anything below 3 will give us an outlier. So let's go back and check our scores, and we can see that one of our scores will be below 3, so 2 is considered an outlier. Okay, we've got a project network here, so let's look at creating a project. We've got to have a start point. We have 3 activities coming off that start point because they don't have any predecessors, okay? So A, B, and A, B, and A, B. So we've got 3 activities that will follow AB, meaning they can't start till AB finishes. So AB finishes, we've got 1, 2, 3 activities. That is D, E, and F. So E and F and E and F have to finish as well before G and H can start. So we can see that D has to go straight to the end. So E and F, they finish, and then G and H will start when they finish. So let's finish those. And then we've got two activities coming off there. That would be G and H, and they go straight to the end because they are the final activities. And then we've got C here, which simply goes straight to the end as well. And there's our project network. Alright, so they want to list the activities on the critical path. So let's find the minimum completion time critical path. So 7 and 18 gives me 25, 15, 10 is 25, 15, 12 is 27, and C is obviously 24. So the minimum completion time there is 27. Remember, you're going to get follow-through marks here if you make a mistake in the network above, so never leave it blank. So we can still gain a couple marks there. So we've got 27 days, remember the units. And let's go back and look at our critical path here. So 27, and let's follow 27 back, and then back through. And there's our critical path. So we'll write that down. A, F, and G. And that's our critical path. Alright, consider each of the questions below in isolation. How many days can E be delayed without an increase in the minimum completion time? Alright, so let's have a look at where E is. So E's here. Alright, and we've got 15 and 12. So the difference between 15 and 12 is 3. And because 15 is on the critical path, there's going to be a 3-day slackness there, or 3 days that it can be delayed. If the time taken by activity F is halved, what effect does this have on the minimum completion time and critical path? Alright, so let's halve F and see what happens here. So let's see what happens if F is equal to 4. So 7 and 4 will actually make 11. Alright, so let's do this network and see what changes it happens. So 7 and 4, that'll actually change the 15 to an 11. Which means we'll change 15 in here to become 12. Okay, because that'll be the minimum completion time before G and H can start. So when we have that 12, we're going to have 24 changed. We're going to have our 25 changed to 22. 12 and 10 becomes 22. And therefore, we're going to have a change in our critical path. So our new critical path is actually going to be A to D. So it's going to change that, and it's also going to change our minimum completion time as well. So remember, it's got 2 marks there, so it changes the critical path to A to D. And remember, it reduces the minimum completion time there as well. And it's always good to state by how much, by 2 days, or it's reduced it down to 25. Okay, question 6. Product rule. Simply look at your formula sheet. Remember, this is what I've done in class with you guys. So U and U dash, V and V dash, and then we multiply them through. So we're going to go U, which is T squared take 2, multiplied by V dash, which is negative 3 plus 4T. And then we're going to add in 2T multiplied by 1 take 3T plus 2T squared. Now the important thing here is it says simplify your answer. So look, let's expand out our bracket there. Take your time with the negatives. Very simple mistakes to make. Okay, now let's try and simplify here our cubes with cubes. So 4t cubed gives me 8t cubed. Let's look at our next one, which is squared. Negative 3t minus 6t is minus 9t squared. Alright, and then our t's, we got minus 8t plus 2t, which is minus 6t. And then we got plus 6 there by itself. And there it is simplified. Alright, we've got a function that passes through the point 1, negative 2, and is such that the gradient function is equal to 5 take 2x. Remember, the gradient function allows us to find the gradient at a point on our function. We've been given a point at x equals 1, so we can actually find a gradient which allows us to find the equation of a tangent. Alright, so the gradient here at x equals 1 will simply be 5 take 2 times 1, which gives you 3. Therefore, for a tangent, we're going to have the gradient of the tangent at that point being y is equal to 3x plus c. And all we need to do is find plus c. Now we've got a point 1, negative 2, which means we simply just substitute that point in. So we're going to have negative 2 is equal to 3 lots of 1 plus c, and therefore c is equal to negative 5. And there is our equation for our tangent, y equals 3x take 5. We'll leave that bottom question. That's not in the course anymore. Okay, prove that the product of any two odd numbers will always be an odd number. Okay, so algebraically we need to prove this. Two different odd numbers, therefore we're going to have 2n plus 1 and 2n plus 1, and we're going to expand out that to get 4mn plus 2m plus 2n plus 1. Okay, in order to show that it's going to be a product, we've actually got to have a factor of 2 pulled out, and we've got to have a plus 1 on the end. So it's going to be in the form of 2p plus 1. Because it's in this form of 2p plus 1, 2p provides us with an even number, plus 1 will always provide us with an odd number. Therefore, it will always be an odd number. Okay, we've got a polygon, two-dimensional shape, made of straight lines with only one boundary. Okay, so let's start with a triangle. It just wants us to state whether the conjecture is true or false and justify answer. So the area of this has got to be bigger than an area of a shape that has more sides. Alright, so I'm going to draw a kite here that's very, very thin, but has sides D also. And without even having to calculate the area, we can clearly see that the area of this kite here will be smaller than the area of this triangle. And therefore, the conjecture is actually false. So we didn't have to prove anything here by using algebraic means. We didn't have to find the area of each of these shapes. We can clearly see through a visual that it's not going to be the same area, so it's false.